Hi everyone, I'm Jackie, and today in this video I will be covering the March 2025 SAT predictions. Before we jump in, friendly reminder to like, rate, subscribe if you like this video, and per usual, let's jump in. Okay, so first, functions. Definitely going to be on the exam. How they will be tested, I believe in one of the following ways. So first one, let's take a look. I have x, I have g of x, and then it tells me the table shows three values of x and their corresponding values of g of x, where g of x is equal to f of x over x plus 5. And f is a linear function. Important. What is the y-coordinate of the y-intercept of the graph of y equals f of x in the xy plane? So remember, y-intercept is when x is equal to 0. Okay. So first, what I'm going to do is let's take our amazing function, g of x equals f of x over x plus 5. I can multiply each side by x plus 5. So this is basically g of x times x plus 5 is equal to f of x. And remember, that's what I'm looking to solve for. Now, I take the coordinates negative 25 and positive 4, and then I can substitute them in. Because what this is telling me for x equals negative 25, it gives me that g of negative 25, just to put here, is equal to 4. Okay, so let's plug that into our amazing function here. So remember we have f of x, which I've just defined here, and I'm going to plug in for g of x times x plus 5. In this case, I'm finding for f of negative 25 to see what values that will give me. So let's go ahead and see. So here, I know that the output, it's 4. So I'm going to go ahead, substitute that in. And then this would be negative 25 plus 5. And when I do that, it tells me that for f of negative 25, the output will be 4 times negative 20, which is negative 80. Interesting. Let's also do the same with the next pair of coordinates, negative 9, 0. So if x equals negative 9, then g of negative 9 is equal to 0. Amazing. So therefore, f of negative 9 is going to be equal to 0 times negative 9 plus 5, and 0 times any number, it's going to be equal to 0. Amazing. And just to show the third coordinate here, so again, if I did x equals 15, we would have g of 15 gives me an output of 6. And then if I plug that in, I get f of 15 would be equal to 6 times 15 plus 5, or 6 times 20. So the f of 15 gives me an output of 120. So I have these amazing points, negative 25, negative 80, negative 9, 0, and 15 and 120. Now, I know it's a linear function, so therefore I can use the slope formula to deduce what the slope is. You can take any of the coordinates. Let's just do, for example, these two, 120 minus 0 over 15 minus negative 9. Careful, it becomes positive here. So this would be 120 divided by 24, which equals, oh my goodness, goes in perfectly, 5. And then, so I know that the slope of this line will be y equals 5x plus b. And then I know that we have negative 9, 0. And I can use that to find what the y-intercept is. I can use any coordinate, just choosing this one because it's lower. So 0 equals 5 times negative 9 plus 45 b, so 45 is equal to b. So final linear equation, y equals 5x plus 45. And then final step, I'm asked what the y coordinate of the y-intercept is. So y-intercept is when x equals 0, but if I'm asked specifically for the y-intercept, we can see it here. It is 45. And that would be the answer that I type in to this amazing problem. Okay, so this one, another function that you should know for the SAT. So here, the table shows three values of x and their corresponding values of y, where s is constant. There is a linear relationship between x and y. Which of the following equations represents this relationship? Okay, so for this one, since I am looking for the relationship between x and y, and our goal is to determine which equation of A, B, C, and D correctly models this relationship. A valid approach and maybe a quick approach would just be to plug in the coordinates, for example, like -2s and 20, and see which one would be a point on that line. So for example, here, if I plug in s, -2s for the x value, plus 4 times 20, I want to basically see if this is going to equate to 12s. This would give me -2s squared plus 80, which does not equal 12s. So not like in option A. If we look at option B, so for -2s plus s times 20, does that equal 12s? Well, this would have -8s plus 20s equals 12s. And that gives me directly that 12s is equal to 12s. So I'm really liking that option. It would work for all the other coordinates too. Um, I think this way could be the quickest way. It's fast, easy, and I'm just seeing if it is proven to be true. We could also find the slope, derive it, see which equation it works with, but I'm trying to solve that fastly, quickly. So I'm liking my plugging in method. Continuing our journey. Okay, the function f is defined by f of x equals ax squared plus bx plus c, a parabola, where a, b, and c are constants, and one, well, a is in between 1, but not bigger than 41. The graph of y equals f of x passes through the points 12, 0, and -4, 0. If a is an integer, what could be the value of a plus b? Okay, well, first, y equals 0. These are the x-intercepts of the parabola. So I can derive the equation. So roots form, y equals a, x minus root 1, multiplied by x minus root 2. And it'd be -12 and plus 4. Next, let's expand our brackets. So this would be x squared plus 4, so -8x, minus 48. And then I distribute the 8 everything. So ax squared minus 8ax minus 48a is our quadratic equation. So it says if a is an integer, what could be the value of a plus b? Well, there's a lot of options, but let's see. So I know a is equal to a, and b is equal to -8a. So if I do a plus b, that'd be a plus -8a, which gives me -7a. And I know that our value of a it's bigger than 1, but it's less than 41. So I could do, for example, 2 for a. So -7 times 2, which is -14. That would be one possibility. You could also do like -7 times 3, which would equal -21. So you could also put -21 as an answer. So pretty much all the answers ranging from our A values from like 2 to 40, you could put in, and that would be an acceptable answer. Wide range of answers, but could appear on the SAT. Continuing our function journey. Oh my goodness, SAT classic. A computer repair specialist charges $160 for the first 2 hours of repair, plus an hourly fee for each additional hour. The total cost for 4 hours of repair is $240. Which function f of x gives the total cost in dollars for x hours of repair, where x is greater than or equal to. Okay, well, I could derive an equation for this one, although personally I would just substitute, but I'm going to show both ways. Okay, so I know that for 4 hours of repair, it's $240, and the first 2 hours, it's $160. So if I want to see what the cost for each hour is, I would take the flat, well, the $160 for the first 2 hours. Now there's 2 additional hours to be, this is my hourly fee that I need to determine, and that will equal 240. So I get that 2h is equal to 80, and the hourly fee is equal to 40. So the hourly charge for each additional hour after the first two, it's $40 per hour. So if I want to set that into a function, I'd be like, all right, f of x is equal to our flat fee, the y-intercept of $160 plus $40 per hour. But careful, I have to subtract out that first 2 hours where I had the flat fee of $160. And dt, this would be 40x minus 80. And that will give me the correct answer choice, 40x plus 80, which seems to match option A. Okay, but so here, since they tell me the total cost for $4 is 240, another thing I could do is just say, like, plug in the 4 and see if it equals 240, which this does. I see a lot of students are inclined to choose option B as the answer, but if I do this, 4 times 4, 160, 160 plus 160, that does not equate to our desired answer, 240. That would equal 320. So you can plug in, or you can solve algebraically as well. Amazing. Oh my goodness, a linear module. Okay, so the linear model estimates the population of a city from 1993 to 2017. The model estimates the population was 52,000 in 1993, 219,000 in 2013, and X thousand in 2017. To the nearest whole number, what is the value of X? Okay. Well, since I know that it is a linear module, I can express these coordinates as X and Y values. So basically, it'd be like year and population would be our y-axis, X, Y. So I have 52,000 in 1993. So 1993, population's 52. In 2013, it's 219,000. And in 2017, which we're trying to solve for, it's X. Okay, so now I would use the slope formula, y2 minus y1 over x2, x coordinate 1 minus x coordinate 2 minus x coordinate 1 equals m. So let's do 219 minus 52 less 2013 minus 1993 and see what that gives us. So this would be over 20. And 219 minus 52, it's 167. Divided by 20, 8.35 is the slope. Okay, so I have y equals 8.35x plus b, the y-intercept. And I'm trying to see uh, how many thousands it was in the year 2017. Okay, so going back here to get our b value, I can take any of the coordinates. Let's go with 52 to get what the b value is. So 8.35 times 1993 plus b, and let us see 8.35 times 1993, which gives me that b is equal to negative 16,589.55. So our final equation is y equals 8.35x minus 16,589.55. Final step would be to substitute this in for the x value. Which will give us the answer. So that gives me y is equal to 252.4. Important, I'm asked to the nearest whole number. So it's going to be 252. And that is our answer. So an amazing question on slope. Okay. Oh, amazing function problem. The function p of x is defined by p of x is equal to a multiplied by x plus 5 squared minus b, x plus 5 squared minus c, where a, b, and c are constants. In the xy plane, the graph of y equals p of x passes through the points negative 630 and 0, 342. What is the value of p negative 10 plus p of negative 4? Okay, so something we should recognize is the function structure. So the x, it only is appearing here with x plus 5 squared, and also here x plus 5 squared, which means that the function depends only on the square of x plus 5, which basically means that the output of p of x is based on the value of x plus 5 squared, not x directly. And squaring creates symmetry. So if two values of x give the same square term, they will produce the same function output. Just to show, before we jump into the problem, how squaring of symmetry works. So if I had x plus 5 squared, the two values of x, just to show. So this would be output at 0, negative 5. So if I took like two other x values, negative 6 and negative 4, they each are evenly spaced 1 away from negative 5, which means that when I square these values, they should give me the same output. And if I do negative 6 plus 5 squared, that gives me 1. And if I do negative 4 plus 5 squared, it's equal to 1. So same squared value gives me the same function output, which is super interesting, I think. So now everyone sees that concept. Let's apply it to our given data here. So I'm told p of negative 6, its output is 30, and also p of 0 gives me an output of 342. So from my previously squared term calculations, I would know then that p of negative 6 must be equal to p of negative 4, which is equal to 30. Everyone sees how p of negative 6 and negative 4 are equidistant to each other. And likewise, if I do the other coordinate pair here, so I have 0, p of 0 is equal to 342. Well, if I think in terms of 0, it can be equidistance to -10. How I can prove that too, because 0 plus 5 squared equals 25. And if I do -10 plus 5 squared, also has the same output of 25. So for that reason, I can also conclude that p of 0 is going to be equal to p of -10, which is going to be equal to 342. Isn't it amazing? So now I basically know what these outputs are, which is just 342 plus 30. And that's all I have to do. Now I just have to sum these. And it is equal to 372. Correct answer. So just remember, squaring always creates symmetry. If two values of x give the same squared result, their function values must be identical. And then you just have to, find the pairs of values with the same squared term, and then we use that to determine the unknown values like we did here. So all based on just understanding of functions and symmetry. Amazing. Continuing our function journey. So here, the table shows three values of x and their corresponding values of y. The linear relationship between x and y can be represented by an equation written in the form ax plus by is equal to c, where a, b, and c are constants. What is the value of a divided by b? Okay, well, simple enough. We can just do the slope formula. It tells me it's linear. So let's find the slope, y2 minus y1, x2 minus x1. And then I can just do, let's go with 43 minus 31 and 2 minus 0. So that will be 12 over 2, which is 6. And that'll be y equals 6x, y-intercept at, the y-intercept is here when x equals 0. So our b value is 31. So here I have this in slope intercept form, but it's asking me to basically convert this into standard form. And that's fine. So let's do that. We have y equals 6x plus 31. So I'm going to move my x over. The y is okay. And that's equal to 31. And then I can see a is equal to -6, b is equal to 1, and c is equal to 31. Everyone sees where I got those. And then final step, a over b, that would just be -6 over 1. And that's our answer, -6. So the function is given as f of x equals 66 multiplied by b to the x power, where b is a positive constant. For every increase in the value of x by 1, the value of f of x increases by c%, where c is greater than 0 but less than 100, which expression gives the value of c in terms of b. Okay, so if x increases by 1, then f of x increases by c%. So basically, like f of x plus 1 over f of x, original function, just represents how much f of x grows when x increases by 1. So I'm going to I'm going to try to find what f of x plus is over f of x. Let's do that. So I just have to substitute x plus 1 here. 66 multiplied by b, x plus 1. Amazing. So another way I could express this with just doing laws of exponents Since I'm adding these, it's the same if I were to multiply b of x by b of 1. You see, this same base, multiplying exponents, we would add the exponents. Um, Amazing. So basically, I can say that f of x plus 1 is basically b being multiplied by f of x. Why is that? Because f of x is 66 by b to the x. So just substituting that in here, it's another way to understand the function. So since the function is increasing by c%, we know that this f of my ratio I did above, f of x plus 1 over f of x is going to increase by c%. So a percent increase would be 1 plus c over 100. Well, going back here, since I'm trying to get this ratio, I can do that. If I do f of x plus 1 over f of x, that's going to be equal to b. And I also know that the function's increasing by c%. So this is also equal to 1 plus c over 100. So basically, I can substitute this in here. And I would have 1 plus c over 100 is equal to b. And I want to get everything in terms of c. So let's do c over 100 equals b minus 1. And then multiply each side by 100. And that will give me c equals 100 b minus 1. Which, oh my goodness, that actually matches an answer, option D. Amazing. Okay. Does that make sense to everyone? If it didn't make sense, that this would be the algebraic approach. But if it didn't make sense, you could always like create different values for this function just to show, because it would work. Like I would have to create b as a positive constant. So I could say like b is equal to 1.2. So the function would be 66 times 1.2, excuse me, x. And for each increase in x, so if I made, let's say, x is 3, then this would just be 66 times 1.2 raised to the third power. If we plug this in on our calculator, would be 114.048. And then I could do the same for each increasing x. So I'm going to increase x by 1, make it 4, and do. So this would give me 136, 8.576. And then I would want to find the percent increase between these two. So basically, remember new minus original divided by original multiplied by 100. Which gives me approximately 20%, which means that like C is equal to 20. And then I would just see if that matches the values when I substitute in B for 1.2. Example, 100, 1.2 minus 1 will give me 100 times 0.2, which is 20%, which would match the prediction here. So you could do it this way by substituting. I could choose any value. I could have made like b equal to 1.5 or 1.6 and then increase x by 1 and then see the percent change difference between them. I just preferred to solve algebraically. Okay, amazing. So know all of those functions, I feel for sure you'll see something similar on March SAT. Amazing. Okay, so geometry and trig. So I'm going to go over new problems in here, but make sure you check out my playlist of March must-know SAT concepts because I go even more in depth of the geometry and trigonometry there. Link to playlist is in the comments. But let's see. So here, shape, volume. So it says the table shows the volume of two similar solids, right circular cylinder A and right circular cylinder B. The radius of right circular cylinder A is 4 units. The surface area of right circular area cylinder A is pi square units, and the surface area of right circular cylinder B is n pi square units, where k and n are constants. What is the value of n minus k? Surface area of a right circular. Okay, so they give us the formula for the surface area of a right circular cylinder. So that's amazing. Um, and also it tells me that these shapes are similar to each other. So since they're similar, that means that their dimensions are proportional to each other by a particular scale factor. So important that you know this for SAT. When dealing with scale factors, I will write here, but it's super important because this has been coming up on pretty much all of the SAT exams. So scale factors. If I want to find the scale factor of any volume of a three-dimensional shape, I would do the cube root to find the scale factor. If I'm looking for area, you do the square root. And you can use the scale factor to find anything that you need to in the problem. So here, since they're similar, what I could do is do the volume. So the volume of like B over the volume of right circular cylinder A, and I'm going to set that equal to scale factor cubed so I can determine what the scale factor is. So let's do that. 32/4 pi over 112 pi is equal to s cubed. The pi's will cancel nicely. This is 27, goes in perfectly. Take the cubed root. So our scale factor, it's 3. Amazing. And then I also want to use the scale factor to find the surface area ratio. And same concept, surface area B over surface area A. And remember that's scale factor for areas. We do s squared. So here it just tells me that it's n pi over k pi. The pi's will cancel. And I know what s is. Substitute. So n over k is equal to 3 squared. So n is equal to n nk, 9k, sorry. And then I want to find n minus k. So n minus k. Now I know what n is. Substitute. nk minus k is equal to 8k. So I need to determine what k is. And I can do that because from the problem, I'm told 2 pi r squared plus 2 pi rh is the surface area. And I know for cylinder A, it is k pi square units. So I'm going to set k pi and set it equal to 2 pi, its radius, it's 4 squared, plus 2 pi 4h. I still need h, but that's okay. That's okay. Probably should have found that before, but no worries. So, side tangent. So the volume, it's equal to pi r squared times h. I know the volume, it's 112 pi, which is equal to pi r squared h. Divide everything by pi. So I'll get that it's 112 is equal to r squared, which is 4 squared h. So basically 16, and then h is equal to 7. Okay, so now I know the height. Should have done that before, sorry, but now we could put that in here. So that when I simplify, I'll have, this is 32 pi plus the 7 here, so 28 times 2, 56 pi. So I have k pi is equal to 56 plus 32, 88 pi. Divide each side by pi. So I get that k is equal to 88, which is amazing because I know what n is. N is equal to 9 times 88, 792, and n minus k, 792, oops, minus k, 88, which is our correct answer, 704. Oh my goodness, so amazing. Okay, but know what I said about scale factors. For volumes, you want to take the cubed root to find the scale factor. Areas, the square root to find the scale factor. So great, so amazing. So continuing our journey. Oh, the function c gives the partial length in centimeters of the circumference of a circle with a radius that measures r centimeters. According to the function, for each increase of 18 centimeters in the length of the radius, the partial length of the circumference increases by k pi centimeters. What is the value of k? Okay, so first, things that jump out to me. I know circumference is equal to 2 pi r. So this is circumference of the circle. So the function, it's giving me a fraction of the total circumference. And if I were to, multiply this further, I can say that it's going to be 4/5 multiplied by pi r. Okay, so since this is a function and I want to find that for each increase of 18 centimeters in length, the partial length increases by k pi. Very rate of change type of language. So if I were to translate this for each increase of 18 centimeters, so if I do like 4/5 pi multiplied by 18 by the radius, it's supposed to equate to k over pi. And then I can divide each side by pi and basically do 4/5 multiplied by 18 is equal to k, which will give me 72, right? Yes, 72 over 5, which is equal to k, which that could be work, or 14.4 you could type in. And that's basically the answer. So summary, this is showing that there's a constant rate of change, which is the 4/5 pi r, and which means that for every time radius increases by the same amount, that c of r is going to increase by the same amount. Example, if I did it again, 4/5 pi by the same amount, that would be doubling it to 36. That will give me, uh, we can see that it's 144 over 5 pi, which it just shows that it's going to increase by the difference. So this would be equal to k. Remember, I would subtract out the difference. So 144 fifths minus 72 fifths, just to show the relationship is equal to 72 over 5, thus proving my point that whenever we increase the radius by the same amount, in this case 18 would be the increase, it's going to increase by the same, which will always give us our k value, which is 72 fifths or 14.4. Okay, amazing. Okay, so these have also been coming up on a lot of exams. I feel like they're going to sprinkle them into the March 2025 exam. So just be confident with these interesting shapes. In this case, a right square pyramid. So it says a right square pyramid has a total surface area of 28,160 square inches. And the combined surface area of the four lateral faces of this pyramid is 16,060 square inches. What is the height in inches of this pyramid? Okay, so to give visual, a right square pyramid looks something like this. Its base is a square. And think about if we unfold this right square pyramid, my base is a square, and I would have four triangles, which would be the four lateral faces of this pyramid. Could be drawn slightly better, but just to give you a visual. So folded, unfolded. Okay, so I'm asked to combine surface area. Okay, so I know total surface area. So the total surface area will be basically the area of the square, area of square plus area of the four triangles, which are these here. So if I'm told that the total surface area is 28,160, and that's equal to area of a square, which would be s squared, plus the four lateral faces, it's 16,060. So now I can find what the area of the square is. Let's do that. 12,100 should go imperfectly. Well, 110, I believe. Let me just clarify. Yeah. So 110 is equal to the side, which just means like this is 110, this is 110, this is 110, and this is 110. Okay, so I found the side of each square, and then I'm asked what is the height of this pyramid. So if I want to get the height actually comes, imagine here, this would be the height, but it would come out from the middle. And then we have this. And then this is different. This would be called the slant height. The slant height would be the height of the individual triangles. So like here. Okay, so what do I know? Okay, so right now I know this because this would be 110 divided by 2. And I need to find what the slant height is. Okay, so what I'm going to do, since I know the area of the triangle, so area of one triangle would be 1660 divided by 4, which is 4015. So base times height divided by 2 is equal to 415. The base, I know it's 110. The height is what I'm solving for. Divided by 2, well, okay, equals 415. So 110h equals 8030. So the height, it's 73. Okay, perfect. So slant height, it's 73. This would be 110 divided by 2, 55. And this is what I want to find, the height of the triangle. And my final step then is to do just that. A squared plus b squared equals c squared. A squared we'll say is what I'm solving for. B squared, it's 55 squared. And then c squareds are slant height, which we established is 73 squared. And then final step is to solve. So a squared plus 325 is equal to 73 times 73. Do d, 5329 minus 3025, which is 2304. And then final step, take the square root. Oh my goodness. It's 48. And that is our answer. So amazing. So I do a lot of these more further breakdowns of three-dimensional figures in the must know geometry concepts for March 2025. Check that out, but also know this problem I feel could come up or something similar on the exam. Okay. Oh, classic. Triangles ABC and DEF are similar. Each side length of the triangle ABC is 2 times the corresponding side length of triangle DEF. The area of triangle ABC is 300 square centimeters. What is the area of triangle DEF? So this also just goes back to knowing the scale factor, because remember, scale factor for areas, I'm going to scale them. To determine the scale factor, I would square each side. So in this case, I know, oops, the side of DEF over side of ABC. And then if I square it, this will tell me what the ratio of their areas are, or their scale factor. So this would just be 1/2. It tells me that. Squared, make sure you square the top and the bottom, which is 1/4. So that means like the area of DEF to area of ABC, it has a ratio of 1:4. And then if I know that, so area of DEF would be 1/4 of ABC, which is 300, which is exactly 75. Isn't it amazing? So, and just to show, because if we see the scale factor, imagine like it was 2 and 2. What happens? This would have an area of 1. And then the scale factor, what do? I square each side for the new triangle. So each of these would be 4, which would be 4 times 4 divided by 2, which is which is 8. Oops, messed up. What am I doing? So if it was original, it'd be 2 times 2 divided by 2. Original area 2, square it with the scale factor. which would just be 4 times 4 divided by 2. So 8, which is what we predicted over here, the 1 over 4. So you can see I am applying my knowledge of the scale factor in this problem as well. Amazing. So a polygon has exactly 73 sides if the measure of each of the 73 interior angles of this polygon is 180 p degrees. What is the value of p? Okay, so the measure of each of the 73 interior angles is 180 p degrees. Important, I can find the sum of the interior angles, and this formula is not given to you on the formula sheet, so worth knowing. N minus 2 times 180 degrees, my sides at 73, minus 2 times 180, 71 times 180, which means 12,780 degrees. Okay, so since the polygon, it says that it's each have the same degree measurement, that means it's a regular polygon. All angles are equal. And I can find then the measurement of each degree. I would just divide this by 73 for, again, the 73 sides. And this gives me 175 degrees. That's the measurement of each interior angle. And then final step, I would take this, set it equal to 100, 180p, divide by 180, 180, and I get that p is equal to, that goes in perfectly, 35 over 36. And that would be the answer. Or you could put it into decimal form, 2. Oh my goodness, wasn't that such a great problem? So remember, if you want more geometry, the more geometry, the better equipped you'll be for the exam. Check out the must know concepts of geometry. Link this video. I'll put the link here, but check it out too in the playlist description below. Continuing our journey, problem solving and data analysis part of the exam. So these ones, type of problems of percents, historically, they've appeared on almost every single SAT exam since its inception for international students in 2023. Also US students, but you guys didn't have it until 2024. Okay, so we have the speeds of particles A, B, and C are meters per second, B meters per second, and C meters per second, respectively. The speed of particle A is 7,900, important, like 79 of particle C. So A is 79C. The speed of particle C, it's 0.08 divided by 100 of B. So that'd be 0.00008 B. Which expression represents the value of A plus B in terms of C? Okay, so then I'm going to want to put this in terms of B. So I'm going to divide each side by 0.0008. And remember, there's like an invisible 1 here. So if I do that, 1 divided by 0.00008, my goodness, it is 12,500 C is equal to B. And then final step, 8 plus B, 79. 79C plus 12,500 C, which is equal to 12,579. Okay, so main takeaway for this problem, be careful of the percents. Make sure you divide them over 100 like I did. And that will be the key to success. Okay, another part of data and statistics are statistic type problems. So data set F consists of 55 integers where the value of each integer is between 150 and 260. Okay, well, so F we could say 150 to 260. And then data set G consists of the same integers as well as integer 10. So it has like 10, 150, and then goes up to 260. Which of the following must be less for data set G than for data set F? Okay, well, definitely the mean, it's going to be affected because if you ever add a lower number to a set, even if all the other numbers are the same, it's going to decrease the overall average. So that's a fact and will always be true. So this will be less than for data set G than for data set F. Yes, so data set G, it's going to be less. G is less than F. And then the median, so here we have 55 values, which means that if it's 55 values, the median will be the 28th value precisely. And then here there's 56 values, which means that the median will be between the 28th and 29th. So you'll have to take the average of the 28th and 29th value. However, since like 10 is added at the very beginning, and imagine if all of these are the same integers, then the 28th and 29th value will remain unchanged. So that's all I have to know. And it's only the average that's going to change. So amazing statistical theory and concept. Okay, let's jump into advanced algebra.
What about this one? So it says the expression 6x to the fourth power plus 17x squared plus 7 can be written as 3x squared plus a multiplied by 2x squared plus b. And it says where a and b are positive integers. Okay, so first let's deal with this. Hold on. Okay, I just wanted to make more room. So let's make this 6x to the fourth, expand the brackets, right? So this would be plus 3bx squared plus 2ax squared plus ab. And then looking at equation equivalences, I see 6x4 equals to 6x4. Looking at the x squares in front, so 17 must be equal to 3b plus 2a. And I also know that AB would be equal to 7. Okay, so it does say that these are A and B are positive integers. So 7 is a prime number, therefore it only has two factors. So either A is 1 and B is 7, or A is 7 and B is 1. I don't know quite yet, but I can determine that with this equation. Because let's see, it must be that B is 7, or sorry, it must be that B is 1 and that 2A is equal to 7, because that would be the only condition in which this would equate to 17. Okay, so I know for sure that B is equal to 1 and A is equal to 7 in this case. All right, so I have value of A, but now I need to get C. More complicated. So here, again, we have the same. I would have this is equal to 6x to the fourth plus 17x squared plus 7, and this is equal to 3x squared uh, plus c, and oops, 2x squared plus d. Okay, so expanding the brackets, yes, again, we would have 6x to the fourth, and then here we would have 2 uh 3d x squared plus 2c x squared plus cd. I ran out of space. But anyways, I can see again that 3d plus 2c, you see how I'm using the coefficients in front of the x squares, is equal to 17. And also um, the 7 here would be equal to c times d. Okay, so this one's a bit more complicated because it tells me that C and D are positive non-integers, meaning it can be um, maybe a fraction or a decimal. And I have the conditions that multiplied together, it has to equate to 7, right? C times D, and 3D plus 2C equals 17. So we do have two equations. So I can maybe rearrange. Let's do 7. So for example, like 7 over D is equal to C. Then I can put that in for C. So I have 3D plus 2 over 7 over D is equal to 17. And that would be 3D plus 14 over D is equal to 17. Now I will multiply each side by D to cancel out the D here. So I would have 3D squared plus 14 is equal to 17d. And you see I'm getting a nice quadratic equation. So 3d squared minus 17d plus 14 is equal to 0. And this is factorable. So I'm going to solve by factoring. You could alternatively do quadratic equation, but it'd be faster to do just this is the same as 3d minus 14, and then d minus 1 equals 0. And then here I would get that my two values. So 3d minus 14 equals 0. 3d equals 14. D equals 14 over 3. And then the other one is just d equals 1. But d can't equal 1 because it has to be a non-integer. So now I know that d is equal to 14 thirds. Um, and then knowing that, so 7 equals, I should have solved for c directly, I suppose, but equals c 14 over 3. And now I can solve for what 3 is, which would just multiply by the reciprocal. Do d, which is 3 3 halves is equal to c. Okay, so now I have that. And also just to show in case you didn't get how I factored it so quickly, I could go through a whole process of factoring, but an alternative way would just be to whip out your Desmos calculator. I just put x instead of the d, and then I can see where the x-intercepts are, which there's 1 at 1, 0, which was exactly what I solved for, right? D minus 1. And then this 4.66667, that's 14 thirds. So just a quicker way to do it. Okay, and then final step, I am asked for a plus c, which would be 7 plus 3 halves. And adding those together, we have 7 plus 3 halves, which is the same as 1.5. So that would just be 8.5 or 17 halves. Amazing. Alrighty, now let's look at this one. Okay, so this says which of the following expressions has a factor of x plus 2b, where b is a positive integer constant? If you've been following my videos, I put this in my June predictions video, not this exact problem, because there was a similar one that appeared in October. There's ones that appeared in May. It could be possible that they bring this up again on the December exam. It won't be probably the same problem. Numbers may be changed, but same concept. So make sure you know this. Okay, so it says it has a factor of x plus 2b. And just to see, like, I'm scanning the answer choices. I see all of these values are the same, and the C values are also the same, 14b. So that's going to make my life a lot simpler, I think. So, for example, if I have x plus 2b, then I can create, um, this must be 3x. Why? Because x times 3x will give me the 3x squared. And then for some constant k that I don't know. And that's going to be equal to, let's just do this for option A for now and see what happens. So this would be 3x squared plus kx plus 6bx plus 2bk. And this is equal to answer choice A, 3x squared plus 7x plus 14b. So we can see 3x squared correlates to 3x squared. Also here, I can factor out the x here. So x, k plus 6b. In this case, this would be equal to 7. And I'm using, again, the coefficients in front. And then I would have 2bk is equal to 14b. Now I can easily solve for what k is, right? Because divide each side by 2b, k equals 7. And then here I have k plus 6b is equal to 7. I know what k is now. It's 7 plus 6b equals 7. 6b equals 0. B equals 0. That doesn't work because it's not giving me b as a positive integer constant. So I must continue the journey. However, my expression, it's going to be the same in each of them. I'll write out one more for b, but it would be the same that it becomes. I would expand x plus 2b is equal to 3x plus k. It expands to this, and then I could see um, that basically, okay, one more written out, plus kx. Oh no, wait. Okay, so 3x squared plus kx plus 6bx, so exactly the same as above. And this will be equal to, now I'm doing b, 3x squared plus 16x plus 14b. And then again, I can see, right, that the 2bk equals to 14b. That's going to be true in every case. So again, I get that k is equal to 7. And then here it would be that k plus 6b is now equal to 16. And then I would do 7 plus 6b is equal to 16. 6b equals 16 minus 7. Um, which is 9. And then I have that it's 9 divided by 6. So that would be another fraction, 3/2. So it doesn't work. But anyways, like I'm writing it out here for you guys to see the whole process, but I wouldn't keep expanding here. Like I see that it's always going to be that k is equal to 7, and that I'm just setting this expression equal to my b value. So now in C, I would just do that. I'd be like, okay, so k plus 6b, well, and just to even put it simpler, it'd be, okay, let me just write it. K plus 2b is equal to 18. And again, I know my 7 plus 2b is equal to 18. So 2b equals 11. B is equal to 11 divided by 2 does not give me a positive integer constant. Okay. And I'm so sorry. I wrote that incorrectly. I thought something seemed off, but it still won't work. But it was k plus 6b. I put 2b. Very sorry. Um, Good thing I caught it now. Okay, so k plus 6b, it's equal to 18. So, and then we do 7 plus 6b is equal to 18. 6b equals 11. And b 11 over 6, again, does not go in. So it's got to be d. but just to show why D would be our answer. So again, 6 plus 6b is equal to 25. 7 plus 6b is equal to 25. 25 minus 7, that is, oh my goodness, 18, and b is equal to 3. This is the only answer choice that gave me a positive integer constant. The rest gave me either 0 or fractions, or aka non-integers. So that's why it's D. I would know this problem. It's already come up on multiple SAT exams.
Okay, so here we have this amazing problem, and it gives me an equation, and it says, in the given equation, k is a positive constant. The product of the solutions to the equation is 77. What is the value of k? So let's see. First of all, everything's in terms of 0. So what I can do is just take 4x plus 7, set equal to 0. Put x plus the square root of 4k plus 7 also equal to 0. And then x minus the square root of 4k plus 7 and also equal it to 0. In doing so, I can now put everything in terms of x. So this would be negative square root of 4k plus 7. And here would be positive 4k plus 7. Note that these two terms are basically the same, just their sign is different. And since I'm asked for the product of the solutions, I can now take those three solutions and set them, well, multiply them together to get their product and set it equal to 77. So I would have a negative 7/4 multiplied by negative 4k plus 7 multiplied by 4k plus 7. Next, note when you multiply the square root, like for example, square root 2 times square root 2, it's 2. So when you multiply the same root, same square root by itself, it will just be that number. It's like squaring it. It'll be that number without the root. So if I do that, then I would basically just have negative 7/4 multiplied. It is negative, so by negative 4k plus 7. And then note, I have two negatives. Negative times negative will become positive. This is all equal to 77. So I'm just going to take this up here. So basically I have 7/4 times 4k plus 7 equals 77. And next I can now solve for our answer. So I'm just going to multiply each side by 4, cancel the 4 here. And then we would have 28k plus 49 is equal to 308. And subtract 49 from 308. So I have 28k is equal to 259. And then final step, divide by 28. And I get that k is equal to 9.25. Which, or 37/4. Both of those answers would be viable. This is an SAT classic. This concept has appeared on multiple official past exams. Feel like it's good to know for March. Continuing our journey. Oh, amazing. The given expression can be rewritten as a over 6x squared plus b over 6x plus c over x. Okay. And note to me, like, oh, that's like ax squared plus bx plus c, where a, b, and c are constants. What is the value of a plus b plus c? Okay. So if I'm to write this out, do 4, 5x minus 4 squared, and it can be written as a over 6x squared plus b over 6x plus c over 6. So here, and in any problem where you're asked to find the coefficients, in this case, A, B, and C, they are the coefficients in front of the x squared and x and c values. So we can do something called the coefficient sum trick, which just means that I can substitute x equals 1 and it will give me directly the sum of the coefficients because it will collapse all of the powers of x to 1. So in our given expression, I'm going to put x equals 1. This is a little trick. Okay, so I'm going to do negative 16, 5 times 1 minus 3 squared. This saves me time, so I don't have to go expand all of the um, brackets and do long algebra, yada, yada, yada. Okay, so then this will just simplify to negative 16 multiplied by 2 squared plus 4 times 1 squared. And then that will be equal to um, like a plus b plus c all over 6. And then I can simplify this further. This would be 4. So negative 64 plus 4 is equal to a plus b plus c over 6. So negative 60 equals a plus b plus c, oops, over 6. And multiply each side by 6. So that will give me negative 360, which is equal to a plus b plus c. And that is our answer. And oh my goodness, it matches correct choice option A. So do the coefficient sum trick if you're ever asked to find the coefficients like you are here. It does happen a lot in SAT. And as you can see, you can solve it really quickly. Continuing our journey. Okay, so this one, we have an equation. It says in the given equation, A and K are constants where K is greater than 4A. The sum of the solutions to the equation, it's 3K plus 35. What is the value of A? So here, since I recognize it's a quadratic equation, what jumps to mind whenever I see sum of solutions is the shortcut of doing negative B over A. So first I'm going to expand these brackets, and friendly reminder, make sure you always expand the parentheses. Never distribute the square to the terms. I know that you probably know that, but just saying to be careful. Okay, so when we expand, it'll become x squared minus 2kx plus k squared, and then that would be equal to minus k squared. And I could factor out the x, so that'd be like k minus 4a, and then plus 4ak. Okay, now I want to put everything in terms of 0. Let's do that. Okay, so basically we'd have x squared minus qkx minus like xk minus 4a plus k squared minus 4ak is equal to 0. Okay. Again, I'm going to put my coefficient of x. I will factor it out. So I have x, then it'd be 2k plus k minus 4a, and then plus basically 2k squared minus 4ak. Okay. Well, and since I care about the b value, just going to make it a little bit nicer. This would be 3k minus 4a. And then plus 2k squared minus 4ak equals 0. Okay. And then using the negative b divided by 2a, I take the coefficients in front of, and remember this is like my ax squared plus bx plus c equals 0. So I actually only care about the b term, and the a term, which is 1. So I would just take our b value, and notice here it's negative. So it's negative 3k minus 4a, but it will get canceled, so it becomes positive. So basically, it's just 3k minus 4 over 1, and this is equal to 3k plus 35. And, having the 1, it's basically equal to the same. And then I can solve for a. So subtracting, I would get negative 4a is equal to 35. And then a is equal to negative 35 over 4. And that would be my final answer. Wasn't it amazing? So remember, if you get some of the solutions and you recognize it's a quadratic equation, shortcut formula, it's called Vieta's formula. You don't have to know the name of it. You just have to know the shortcut. Okay, amazing. Continuing our journey. Well, it is this one. In the given equation, R and S are positive constants. The product of the solutions to the given equation is KRS, where K is a constant. What is the value of K? So same thing. I recognize that this is quadratic equation. If it's quadratic equation as for product of the solutions, the shortcut formula, it's C over A. This one's simpler than the first because everything's already expanded. My C value, it's RS, and my A value is 21. So I'm going to do that. RS over 21 is equal to KRS, provided here in the formula. Multiply each side by 21. Divide by RS. When you divide by RS, this would just become 1, which equals 21k, and 1 over 21 equals k. Super short, super fast, just applying the shortcuts. These have appeared on multiple official SAT exams. Make sure you know them and how to do them. Recognize when it's a quadratic equation, you can do this. Oh, exponents. Okay, so exponents, make sure you check out my video in the must know exponents for the March SAT exam if you want to deep dive into this more, but you need to know your laws of exponents for the SAT. Okay, so for this one, in the given equation, m is a constant and x is square root of 1. The expression can be written as the square root of x. What is the value of m? So whenever you have, this is the fifth root. So basically another way I could re-express this is x over m divided by 5. So I want to take everything out of the roots and make them exponents. Likewise, the square root of x, there's always an invisible 2 here and a 1 here. So this is the same as x to the 1/2. So if this can be rewritten as this, now I have my bases the same. And now I can just set the exponents equal to each other. And then you'd have 2m is equal to 5 and m is equal to 5/2. Simple question, but you can see it's all about knowing your laws of exponents pretty solid. So make sure you know them. And again, if you want more of a deep dive, check out the must know SAT concepts, the playlist. I've linked it below in the description, as well as I'll set the link here if I'm capable of doing that. Okay, so continue into no solutions and infinite solutions. These are on every single SAT exam. You'll either see no solutions or infinite solutions, or maybe you'll see both. But I always tell students, feel really comfortable solving these problems. Okay, so here, classic, which system of linear equations has no solution? No solution means they have the same slope, but they have a different y-intercept. If they don't have a different y-intercept, then they are the same line and have infinite solutions. A very important difference. So for these ones, I suppose you could use Desmos, plug them in and see which ones are parallel. Or we can rearrange in terms of y and then see what the slope specifically is. So here, just to show, be 8y is equal to 2x plus 5, which simplifies to 1/4 x plus 5/8. And here, this would be negative 8y is equal to negative 2x plus 5, which gives me y equals positive 1/4 x minus 5/8. This works because they have the same slope and they do have a different y-intercept. Notice it's negative versus positive, so these are parallel lines, and that would be our winner. So here it works out nicely because it just happens to be A. Any other answer choice that has a different slope would have one solution. They would cross at one point if they're a linear equation. And just be super careful for the equations that are infinite solutions. So same line, same y-intercept. But I'm going to stop there to save time. You see, always rearrange in terms of y, get what the slope is, and check that they have different y-intercepts. Amazing. Okay, here in the given equation, r and s are constants. The equation has no solution. What is the value of r? So again, I know that they're parallel lines, which means they have the same slope. And really, looking at this equation, I'm asked for the value of r. So if I'm asked for the value of r, and this would be like mx plus b, and this would be like b minus mx. So this would be the slope here, and here would be the slope. So I can take those two, negative 3/19 r, and set equal to negative 5/57. And then I can just solve for r. So this would be 19 times 5. So we would have we would have 95. Um, basically, it's equal to negative 5 times 19 over negative 3 times 57, which gives me positive 95 over 171. And that would be the answer. So you see, I can solve these ones really quickly just by recognizing language in the problem, being like, oh, parallel lines have the same slope, set the slopes equal to each other. And okay, so let's look at this one. Oh, a graph. The graph of line G is shown in the xy plane. Line K is defined by 165x plus py equals w, where p and w are constants. If line K is graphed in this xy plane, resulting in the graph of a system of two linear equations, the system of equations will have infinitely many solutions. So remember, this is same slope and same y-intercept. Basically, they're the same line, aka same line. Okay, so what I would do here is if they give me two coordinates, let's take them. So that is at negative 10 and 12. And this one here, it's at 0, 1, the y-intercept. Okay, so let's find the equation of the graph line. So slope would be 12 minus 1, negative 10 minus 0, 11 over negative 10s. Amazing. So the equation of this line is y equals negative 11/10 x. And my b value, it's the y-intercept where x equals 0, which we can already see here. It's 1. Okay, and it says that, so this was line G and line K is defined by this. So what I would do for line K is just put everything in terms of y. So this would be py is equal to negative 165x plus w, and then divide everything by p. So y is equal to negative 165 over px plus w over p. And remember, same slope is the same. They have the same slope and the same y-intercept if they have infinitely many solutions because they're the same line. So now I take the slope here. Let's do that. So that would be negative 11/10 is equal to negative 165 over p. So negative 11p is equal to negative 160,650. And divide by 11. Oh my goodness, goes in perfectly. 150. So now I know what P is. And likewise, it tells me that 1 is equal to W over P. So 1 over 1 equals W over P. And I know that P, it's 150. Substitute. So 1 is equal to W over 150 multiply each side by 150. So also W is equal to 150. And then final step to get the value of P plus W, I would do 150 plus 150, which of course is 300. And that would be our answer. Isn't it so amazing? So know the language in the problem, no solutions, infinite solutions, guarantee you'll see one or the other on the exam. I would bet, well, I don't know, but I would bet a lot of money that it's going to be on the exam. Okay. And let's take a look at this one. This one's really interesting. The given equation is the given equation is one equation in a system of two linear equations. If the equation has at least one solution, which of the following equations could be the other equation in the system? Okay, what does at least mean? That it has one or more. So first, what I would do is see what the slopes are. So here, rearrange 3y is equal to negative 6x plus 5. So this would be negative 2x plus 5/3 is the equation of this line. So now let's check what 1 is. So 1, it's 9x plus 4.5y is equal to 7.5. Negative 9x plus 7.5. Divide everything by 4.5. So this would be negative 2x. Oh my. Over 5/3. So 1, it's the same line, but careful with this because it says one or more solutions. This means it has infinite solutions. That classifies as at least one solution. So therefore, 1 works. So that could be a other equation in the system. And then this one will basically be the same, except so negative 4.5 y equals negative 9x plus 7.5. And then I divide everything. So this will give me positive 2x and then minus 5/3. So this is a totally different equation, different slope, but that means that it will intersect at one point. So this will also have one solution. So this one's infinite solutions. And this is one solution. And therefore, answer would be 1 and 2. So really careful with the language, like at least one solution. And guys, our journey for my math March 2025 SAT predictions has come to an end. So if you're looking for more practice on any of these problems, check out the playlist of the March 2025 must know SAT concepts. I go over functions in depth. I go over no solutions, infinite solutions, manipulating equations, the discriminant, percents, factoring, a lot of different concepts, even more in depth than this one. Also, check out my other predictions linked below. I always tell students that if you want more practice, check out my other predictions. They're applicable for any exam that you're taking for the SAT so that you feel super prepared and go in confident knowing all the problems. And that's it. I will do reading and writing predictions soon. And if you like this video, like, rate, subscribe. Thank you so much for watching, and I will see you in the next video. Bye.